Welcome. Tonight, there is nowhere to hurry, nothing to solve, nothing to remember, only a quiet sky stretching above you, and countless stars resting in the darkness. As you settle into a comfortable position, allow your breathing to slow. Take one gentle breath in and another softly out. With every slow exhale, imagine the weight of the day becoming a little lighter. There is only this moment, this calm evening, and a peaceful journey through one of the oldest stories in our solar system. Tonight, we will follow the quiet science of comets, not as objects of fear, but as gentle travelers, frozen visitors that have wandered through space for billions of years. Long before mountains rose on Earth, before oceans filled our planet, before the first living cell appeared, these ancient wanderers were already drifting through the darkness. Their journey has been incredibly slow, so slow that a single trip around the sun can take thousands, or even millions, of years. Imagine that kind of patience. Imagine moving so gently that entire civilizations could rise and disappear while you quietly continued your path through space. There is something comforting about that thought. The universe rarely rushes. Stars are born slowly. Galaxies drift slowly. Even planets take millions of years to grow. Comets simply remind us that nature keeps time differently than we do. Now, close your eyes if they are not already closed. Picture yourself standing beneath a clear night sky. There are no city lights, no traffic, no glowing screens, only cool evening air brushing softly across your face. The ground beneath your feet is still warm from the day's sunshine. Somewhere nearby, a gentle breeze moves through tall grass. Perhaps you hear the faint sound of leaves whispering together. Far above, the stars appear one by one. At first, only the brightest, then hundreds, then thousands. The longer you look, the more the sky seems to awaken. Among these familiar stars, something unusual appears. Not bright, not dramatic, just a faint little glow, almost like a tiny cloud that somehow wandered into space. It does not blink like an airplane. It does not streak across the sky like a meteor. Instead, it moves almost too slowly to notice. Night after night, its position changes ever so slightly, patiently, quietly, almost shyly. Thousands of years ago, people noticed these mysterious visitors. Imagine yourself living in an ancient village. There are no telescopes, no satellites, no electric lights. The night sky is part of everyday life. Every evening, families step outside after sunset. Children point toward familiar constellations. The moon follows its familiar path. The stars rise exactly where they always have. Then, one evening, something new appears. A pale misty light. Small, soft, moving among the stars. No one remembers seeing it before. People gather silently. Some whisper. Others simply watch. No one knows what it is. To them, the sky has always been steady. The stars seemed eternal. Yet this strange visitor moves. Very slowly, almost gracefully. For countless generations, comets were mysterious guests. Some cultures believed they carried messages. Others imagined they were celestial spirits crossing the heavens. Some thought they announced great changes. Yet beneath every story, there was something deeply human. Curiosity. People have always looked upward. Long before science gave us answers, our ancestors searched the stars with wonder. Perhaps that sense of wonder has never truly disappeared. Even today, knowing what comets are does not make them less beautiful. In many ways, understanding them makes them even more extraordinary, because the truth is quieter and far older than the legends. A comet is not a magical light. It is not an omen. It is not a wandering fire. It is a small frozen world. Most are only a few miles across. Some are even smaller. Imagine a mountain made of ancient ice, mixed with dust, tiny rocks, and frozen gases, not smooth like polished ice, but dark, rough, covered with black dust collected over billions of years. If you could stand beside one, it might appear darker than charcoal, hardly the brilliant object we see glowing in photographs. Its beauty comes later, only after sunlight gently begins its work. For most of its existence, a comet lives in silence, far beyond the warmth of the sun, far beyond the planets we know. There, in the deepest darkness, it sleeps. The temperatures are unimaginably cold, so cold that water remains frozen for billions of years. Carbon dioxide freezes, ammonia freezes, methane freezes, even sunlight becomes weak. The sun, which fills our daytime sky with warmth, looks only like an unusually bright star. That distant frozen traveler simply waits, not because it chooses to, but because gravity has placed it on a journey almost impossible for the human mind to imagine. Millions of years may pass. Entire species may appear and disappear on Earth. Still, the comet drifts quietly onward. Sometimes it travels alone. Sometimes countless others surround it in distant regions of the solar system. Together, they form enormous families of ancient objects, silent archives from the birth of everything we know. These frozen travelers preserve pieces of the earliest solar system, tiny time capsules, older than Earth itself. Inside them, scientists have found clues about the ingredients that existed before our planet was fully formed. In a way, every comet carries a memory, not a memory with thoughts or feelings, but a physical memory, frozen material left behind when the sun was young, when the planets were still growing, when the solar system itself was only beginning to take shape. That makes every comet a traveler, not only through space, but through time. As you continue resting, imagine one of these ancient travelers beginning a long journey toward the inner solar system. Not quickly. Nothing in this story happens quickly. Its movement is almost impossible to notice from one day to the next. Yet year after year, century after century, it slowly draws closer to the warmth of the sun, closer to the familiar planets, closer to Earth, closer to the place where curious eyes may someday look upward and quietly whisper, "There it is." No fanfare, no urgency, only another peaceful visit from one of the oldest travelers still wandering through our cosmic neighborhood. And perhaps, as you breathe gently beneath tonight's sky, another unseen comet is already making that journey, still far away, still hidden in darkness, still drifting with endless patience through the silent sea of stars. In the next chapter, we'll travel back more than 4.5 billion years to discover where these quiet wanderers were born, when our solar system was still a swirling cloud of dust, ice, and newborn light. Now, allow your breathing to remain slow and steady. And imagine that the stars above you are beginning to drift backward through time, not by years or centuries, but by billions of years. The familiar solar system slowly fades away. Earth disappears. The moon is gone. The planets have not yet formed. Even the sun, as we know it, does not yet exist. Instead, there is only an enormous cloud floating through a quiet corner of our galaxy. It is difficult to imagine something so vast. This cloud stretches for trillions of miles. It is made mostly of hydrogen gas, mixed with helium, tiny grains of dust, and countless microscopic crystals of ice. Everything drifts peacefully through the darkness. There is no sound, no wind, no up or down, only gentle motion, guided by gravity. This quiet cloud is known as a molecular cloud. It may not look impressive from the outside. It is so thin that a person drifting inside it would hardly notice it at all. Yet hidden within this calm mist lies enough material to create an entire solar system, perhaps even several. For millions of years, almost nothing changes. The cloud slowly moves around the center of the Milky Way. Stars shine far away. Nearby stellar nurseries quietly give birth to new suns. Time flows gently. Then, something changes. Astronomers are not completely certain what begins the process. Perhaps a nearby star reaches the end of its life. Perhaps a distant supernova sends a ripple through space. Or perhaps gravity simply gains the upper hand after countless millions of years. Whatever the cause, one small region of the cloud begins to collapse. Very slowly, gravity gathers more gas, more dust, more ice. The growing mass pulls in even more material. Little by little, the collapse becomes unstoppable. Imagine placing your hand into a calm pond. Tiny ripples spread outward. In a way, gravity creates similar ripples through this enormous cloud. Everything begins moving inward, not quickly. Nature almost never works quickly on this scale. Thousands of years pass, then hundreds of thousands, then millions. At the center, pressure slowly increases. Temperatures rise. The cloud becomes denser, brighter, warmer. Eventually, a young star is born. That young star will become our sun. But the story is only beginning. Around the newborn sun, a great spinning disk stretches across billions of miles. Imagine a giant whirlpool, not made of water, but of dust, gas, and glittering grains of frozen ice. Every tiny particle circles the young sun. Some collide gently, others stick together. Small grains become pebbles. Pebbles become rocks. Rocks become mountain-sized worlds. Given enough time, gravity shapes these growing bodies into planets. Mercury forms close to the sun. Venus begins taking shape. Earth slowly gathers more and more material. Farther away, Jupiter becomes enormous. Saturn follows, then Uranus, then Neptune. Our familiar solar system is quietly assembling itself. It is a beautiful process, not explosive, not chaotic in the way movies often imagine. Instead, it is patient, countless gentle collisions, countless tiny pieces joining together, each small step building towards something much larger. Yet, not every piece finds a home. Scattered throughout the spinning disk remain countless fragments. Some are no larger than grains of sand. Others are the size of mountains. Many never become part of a planet at all. They simply continue circling the sun, waiting. These forgotten leftovers are precious, while planets continue changing over billions of years. These smaller icy bodies remain almost exactly as they were in the beginning. They become frozen archives of the solar system's earliest days. Imagine opening a box that has remained sealed since the very first morning of Earth's history. Inside, everything is almost exactly as it was. That is what many comets are like. They preserve ancient materials that planets have long since changed or buried beneath mountains and oceans. Scientists sometimes call comets cosmic time capsules. It is a fitting description. Inside their frozen layers are tiny grains of dust that formed before Earth even existed. Some minerals may be older than the sun itself. They were created around distant stars, long before our solar system was born, and later became part of this great cosmic cloud. In that sense, every comet carries an even older story, a story written among stars that vanished billions of years ago. Perhaps that is one reason comets feel so mysterious. They connect us to an almost unimaginable past, a past beyond human history, beyond dinosaurs, beyond oceans, beyond the first sunrise on Earth. As the young solar system continues settling into its familiar shape, gravity quietly sorts everything into different neighborhoods. The rocky planets remain close to the sun. The giant gas planets form farther away, and countless icy objects are gently scattered toward the distant edges of the solar system. Some travel outward because of Jupiter's tremendous gravity. Others receive gentle gravitational nudges from Saturn, Uranus, and Neptune. Their journeys are long, slow, and silent. No destination signs, no finish lines, only gravity, patiently guiding every object along its path. Many of these icy worlds will eventually gather in distant regions beyond Neptune. Others will be thrown unimaginably farther away, into the vast darkness surrounding the solar system itself. There, far beyond the warmth of the sun, they will sleep, not for years, not for centuries, but for billions of years, almost unchanged. Imagine the silence. No sunrise, no sunset, only distant stars shining softly across an endless black sky. The tiny frozen world drifts peacefully through space. Its surface remains colder than almost anywhere we can imagine. Every grain of ice waits. Every crystal remains still. Nothing rushes. Nothing grows old in the way it does on Earth. Time itself seems almost asleep. Yet gravity never truly rests. Even across unimaginable distances, it continues its quiet work. One day, perhaps millions of years in the future, the path of one sleeping comet will begin to change. Not because of an explosion, not because of some dramatic event, only because gravity offers the gentlest of invitations. A tiny nudge, almost too small to measure. And that gentle invitation will begin one of the longest journeys in nature. A journey back toward the sun. A journey that will eventually create one of the most beautiful sights in the night sky. But before that happens, we must travel even farther from the warmth of our young star, to the most distant reaches of its invisible kingdom, where countless frozen wanderers rest together in extraordinary silence. There, in a realm so vast that light itself takes more than a year to cross just a small portion of it, we will discover the quiet home of the oldest comets, the mysterious frontier known as the Oort cloud. Now, our journey carries us farther from the warmth of the sun than any spacecraft has ever traveled, far beyond Earth's familiar orbit, past the red deserts of Mars, beyond the swirling clouds of Jupiter, past the graceful rings of Saturn, and beyond the pale blue worlds of Uranus and Neptune. Even Pluto, once considered the ninth planet, has long disappeared behind us. The sunlight grows softer. The warmth fades away. The great planets become tiny points of light. Ahead, there is only darkness. Yet this darkness is not empty. It is peaceful, patient, and filled with quiet possibilities. Take another slow breath and imagine drifting gently through this silent frontier. There is no up, no down, no horizon, only countless stars surrounding you in every direction. The sun, which shines so brilliantly from Earth, now appears as nothing more than a very bright star among millions of others. Its comforting warmth can no longer reach you. Its light still travels across the darkness, but by the time it arrives, it has become soft and gentle. This distant realm marks the beginning of one of the greatest mysteries in astronomy. A place no human has ever seen directly. A place so enormous that even the fastest spacecraft would need thousands of years to cross it. Astronomers call it the Oort cloud, unlike the planets, which travel in nearly the same flat plane around the sun. The Oort cloud surrounds the solar system in every direction. Imagine a tiny glowing lantern sitting inside a giant transparent sphere. The lantern is our sun. The sphere, vast beyond imagination, is the Oort cloud. It does not resemble a ring. It is more like an immense shell, stretching outward into the darkness. Its outer edge may lie almost halfway to the nearest star. That is an astonishing thought. Our solar system does not simply end after Neptune. Its invisible kingdom extends much farther than most people ever imagine. Inside this immense region, billions, perhaps even trillions, of icy bodies drift in quiet solitude. Each one is a comet waiting patiently. Some are only a few hundred feet across. Others measure many miles from end to end. Each follows its own slow path. Yet they are so widely separated that if you stood upon one, you might never see another nearby. Space remains overwhelmingly empty. Silence fills every direction. Imagine standing upon the surface of one of these frozen worlds. The landscape is unlike anything on Earth. The ground is dark, almost black, not because it lacks ice, but because billions of years of cosmic dust have settled across its surface. Tiny grains of carbon-rich material create a blanket darker than fresh asphalt. Beneath that dusty layer rests ancient ice, water ice, frozen carbon dioxide, frozen methane, frozen ammonia. Materials preserved almost perfectly since the earliest days of our solar system. Nothing melts here. Nothing flows. The temperatures remain hundreds of degrees below the freezing point of water. Even the hardest winter night on Earth feels warm compared to this place. If you reach down and touch the surface, your glove would meet something colder than almost any environment nature can create. Yet despite this incredible cold, there is beauty here. Picture distant stars scattered across a perfectly black sky. No atmosphere softens their light. No clouds drift overhead. Every star shines with remarkable clarity. The Milky Way stretches from one horizon to another like a river of quiet silver. It is breathtaking and perfectly still. Here, time seems almost asleep. A single orbit around the sun can require hundreds of thousands, or even millions, of years. Imagine beginning a journey when the first dinosaurs appeared, and not completing one full orbit until long after humanity has vanished. That is the pace of life in the Oort cloud. Nothing feels rushed. Nothing demands attention. Everything simply continues, patiently, steadily, through the endless passage of time. For many years, astronomers wondered where long-period comets came from. Some comets appeared only once in recorded history. Others returned after thousands of years. Their paths arrived from every direction in the sky. There seemed to be no pattern. Then, in 1950, a Dutch astronomer named Jan Oort proposed a remarkable idea. Perhaps, he suggested, the solar system was surrounded by an enormous cloud of frozen objects, a vast reservoir of sleeping comets. Gravity would occasionally disturb one of these distant travelers, sending it gently toward the inner solar system. It was an elegant explanation. Even today, astronomers believe Jan Oort was largely correct, although we have never photographed the Oort cloud directly. The paths of many comets strongly suggest that such a region truly exists. Sometimes, science works this way. Not every discovery begins with a photograph. Some begin with careful observation, patient calculations, and quiet curiosity. The universe often leaves clues instead of clear answers. Scientists simply learn to read those clues. Imagine billions of frozen worlds resting together in peaceful darkness. Each one carries tiny grains of ancient dust. Each preserves chemistry from the birth of our solar system. Together, they form the largest known family of comets surrounding the Sun. Most will never visit Earth. Most will never become bright enough for anyone to notice. They will simply continue their silent orbits. Century after century, age after age, there is something strangely comforting about that thought. Not every beautiful thing must be seen. Not every journey needs an audience. Far beyond our everyday lives, countless quiet travelers continue moving through space, asking nothing, expecting nothing, simply following the gentle pull of gravity. Occasionally, another star passes relatively close to our solar system, not close enough to disturb the planets, but close enough for its gravity to whisper across the Oort cloud. Imagine two ships passing on a calm ocean. Neither touches the other, yet each creates small waves. Those gentle waves spread outward. Gravity behaves in much the same way. A passing star, or even the slow tidal pull of our Milky Way galaxy, can slightly change the path of one sleeping comet. The change is almost unimaginably small, barely enough to notice, yet over millions of years, that tiny change becomes meaningful. A quiet drift begins. The comet slowly starts falling inward. Not rapidly. There are no sudden turns. Only a gradual descent toward the distant warmth of the sun. It is as though gravity softly whispers, "It's time to come home." The comet answers without hesitation, without hurry. Its long inward journey has begun, as it leaves the silent kingdom of the Oort cloud. It enters a voyage that may last millions of years. Ahead lie the giant planets. Beyond them, the warmth of sunlight. Beyond that, perhaps one brief, glowing appearance in Earth's night sky before returning once again to the deep darkness. But not every comet begins its story in the Oort cloud. Closer to the Sun, just beyond Neptune, another remarkable family of icy worlds quietly circles in a broad, frozen ring. It is smaller than the Oort cloud, yet no less fascinating. In our next chapter, we will drift toward that distant frontier, the mysterious and beautiful Kuiper Belt, where many of the solar system's shorter journeys quietly begin. Take another slow breath and imagine turning gently back toward the warmth of the sun. Not all the way to Earth, only part of the journey. We leave behind the immense silence of the Oort cloud, traveling inward across unimaginable distances. The sun grows just a little brighter, still small, still far away, but no longer just another point among countless stars. Ahead, a quiet frontier slowly comes into view. This is not an empty stretch of space. It is a vast ring filled with ancient worlds. Frozen, dark, patient. Astronomers call this distant region the Kuiper Belt. Unlike the Oort cloud, which surrounds the solar system like a great sphere, the Kuiper Belt lies in a broad, flat disk. It follows the same general plane as the planets. Imagine an enormous frozen shoreline surrounding the familiar solar system, a place where countless icy bodies quietly circle the sun. It begins just beyond Neptune, about 30 times farther from the sun than Earth. From there, it stretches outward for billions of miles. If you were drifting here, the sun would still shine, but its light would feel gentle, almost like the soft glow of a bright evening star. Daylight, as we know it, does not exist. The temperatures remain astonishingly cold, around minus 375 degrees Fahrenheit, or nearly minus 225 degrees Celsius. Cold enough that water remains as hard as rock. Nitrogen freezes solid. Methane forms brilliant sheets of ice. Even sunlight seems almost sleepy here. Picture yourself standing upon one of these frozen worlds. The landscape is peaceful beyond words. Low hills covered with ancient frost, gentle slopes disappearing into darkness. No wind, no flowing rivers, no rain. Only quiet stillness beneath a sky filled with countless stars. The silence feels complete, and yet, this region is far from lonely. Scientists estimate that the Kuiper Belt contains hundreds of thousands of icy objects larger than 60 miles across. There may be millions of smaller ones, each quietly following its own path around the sun, each carrying material left over from the birth of the solar system. One of the most famous residents of this distant neighborhood is Pluto. For many years, children learned that Pluto was the ninth planet. Today, astronomers classify it as a dwarf planet. Yet Pluto has lost none of its beauty. In many ways, it has become even more fascinating. When NASA's New Horizons spacecraft flew past Pluto in 2015, it revealed a surprisingly diverse world. Towering mountains made of water ice, vast plains of frozen nitrogen, blue layers of haze suspended high above the surface, heart-shaped plains stretching across the landscape. It was a reminder that even the most distant places can surprise us. Pluto is not alone. Nearby travel many other remarkable worlds. Eris, slightly smaller than Pluto, yet more massive. Haumea, shaped almost like an elongated football because it spins so rapidly. Makemake, covered in bright frozen methane. Quaoar, Orcus, and many others. Each has its own quiet story. Each circles the sun with extraordinary patience. These frozen worlds move slowly. Very slowly. A single year on Pluto lasts about 248 Earth years. Imagine celebrating one birthday every 2.5 centuries. Seasons change so gradually that generations could pass before winter becomes spring. Time itself seems relaxed here. Among these icy neighbors, many short-period comets begin their lives. Unlike the long-period comets arriving from the distant Oort cloud, these travelers usually complete an orbit in less than 200 years. Some return every few decades, others every century or so. One of the best-known examples is Halley's Comet. Although its journey has been shaped by countless gravitational encounters, astronomers believe it likely began in this distant frozen region long ago. The Kuiper Belt acts almost like a quiet nursery. Most of its icy residents remain peacefully in place. But every now and then, gravity gently changes someone's path. Neptune plays an especially important role. The giant blue planet circles just inside the Kuiper Belt. Its gravity reaches far beyond its visible clouds. Imagine Neptune as a patient shepherd, not forcing, not rushing, simply guiding nearby objects over immense stretches of time. Sometimes, an icy body drifts just a little too close. Neptune gives it the gentlest of gravitational nudges, barely noticeable at first, yet over thousands, or millions, of years, that tiny change slowly grows. The object's orbit stretches. Its journey becomes more adventurous. Eventually, it begins traveling toward the inner solar system. Nothing dramatic happens. No sudden acceleration, only gravity, quietly doing what gravity has always done, one peaceful step at a time. Scientists have given a special name to many of these wandering objects. They are called centaurs. Their orbits carry them between the giant planets. They are neither fully settled in the Kuiper Belt, nor yet true comets glowing near the sun. Instead, they spend time wandering among Jupiter, Saturn, Uranus, and Neptune. Some remain there for millions of years. Others continue inward. Each follows its own unique path. The solar system is full of these gentle transitions. Very little changes overnight. Almost everything unfolds slowly, patiently, naturally, as you continue relaxing. Imagine floating high above the Kuiper Belt. Below you, countless frozen worlds circle together like tiny dancers moving to a rhythm so slow that it is almost impossible to perceive. Each orbit is graceful, each path carefully balanced by gravity. No collisions, no chaos, only quiet motion across billions of miles. The stars above remain steady. The sun glows softly in the distance. The icy worlds below continue their endless journey. There is something comforting about such steady movement. Every object knows its path. Every orbit tells a story measured not in days, but in ages. Perhaps that is one of the greatest lessons hidden within the Kuiper Belt. The universe does not hurry. Its finest creations often require unimaginable patience. Worlds form grain by grain. Mountains rise inch by inch. Comets spend billions of years preparing for a journey that humans may witness for only a few weeks. And somehow, that brief appearance in our night sky becomes all the more beautiful because of the incredible patience behind it. One of these quiet travelers has now begun moving inward, still far beyond Neptune, still wrapped in ancient ice. It slowly leaves the peaceful company of the Kuiper Belt behind. Ahead lies the realm of the giant planets. Their powerful gravity will reshape its path again and again, not violently, but with gentle precision. And with every passing century, the frozen traveler draws a little closer to the distant warmth of the sun. In our next chapter, we will accompany this ancient comet as gravity patiently guides it past the giant planets, beginning one of the longest and most beautiful journeys in the solar system. For countless ages, our quiet comet has rested peacefully beyond Neptune. Its frozen surface has known only darkness, starlight, and the faint, distant glow of the sun. Nothing has disturbed its silent routine. Millions of years have passed like quiet breaths. Empires have risen on Earth. Oceans have changed. Entire species have appeared and disappeared. Yet the comet has remained almost exactly the same. It has asked for nothing, expected nothing, simply drifting, patiently, through the cold outskirts of the solar system. Then, almost without noticing, its journey begins to change. Not because of an explosion, not because of a collision, only because of one of the gentlest forces in the universe: gravity. Gravity never shouts. It never rushes. It simply whispers. Day after day, century after century, until even the smallest whisper becomes a new path. Imagine placing a tiny leaf upon a calm lake. A barely noticeable current slowly carries it away. The leaf never feels a sudden push. Yet hour after hour, it quietly finds itself somewhere entirely new. That is how gravity often works in space. One tiny change, repeated patiently, can guide an object across billions of miles. Our comet has wandered just slightly closer to Neptune than before. Not close enough to touch, not even close enough to see details on the planet. Only close enough for Neptune's gravity to offer a gentle invitation. The giant blue world continues peacefully along its own orbit. It never stops. It never turns toward the comet. Yet its enormous mass bends space itself. The comet responds naturally. Its path changes by the smallest imaginable amount. If you could measure the difference, it might seem almost meaningless. A tiny adjustment, barely enough to notice. Yet the universe has endless patience. That tiny adjustment continues growing, year after year, orbit after orbit. Slowly, the comet begins falling inward toward the sun. Not quickly. Even now, its journey remains incredibly slow. Imagine walking one single step every 100 years. That would almost seem fast compared to the pace of some celestial travelers. As the comet moves inward, it encounters another quiet companion, Uranus. Soft blue, calm, graceful. From this distance, its pale atmosphere glows gently beneath the distant sunlight. Its gravity also lends a quiet hand, not enough to capture the comet, only enough to reshape its long path once again. Space is filled with these invisible conversations. No words are spoken, no sounds travel through the vacuum. Yet gravity allows worlds to communicate without voices. Every planet leaves gentle fingerprints upon the paths of passing objects. Each encounter changes the story just a little. Our comet continues onward, still frozen, still dark, still asleep beneath its dusty surface. The sun grows slightly larger ahead, not warm yet, only brighter. Far behind, the Kuiper belt slowly fades into the darkness. Ahead lies Saturn, even from a tremendous distance. Its rings seem almost unreal. Imagine billions of tiny pieces of ice circling together, each one reflecting soft sunlight like scattered diamonds. If you could drift silently above those rings, you would discover they are astonishingly thin, wide enough to span hundreds of thousands of miles, yet often only a few hundred feet thick. Nature has a remarkable way of creating delicate beauty on enormous scales. Saturn's gravity quietly reaches outward. Again, our comet receives another gentle nudge. Nothing dramatic changes. Its speed increases only slightly. Its orbit becomes a little narrower, a little shorter. Each encounter with a giant planet shapes the journey that lies ahead. Perhaps this gradual guidance feels familiar. Sometimes life changes in similar ways, rarely because of one enormous moment, more often through countless tiny moments, small conversations, gentle choices, quiet opportunities. Looking backward, those tiny changes reveal an entirely new path. The universe seems to understand this lesson well. Nothing is wasted. Even the smallest pull matters. Farther inward, the largest planet of all slowly comes into view. Jupiter, a giant so massive that all the other planets combined would still weigh less. Its colorful clouds swirl peacefully around the enormous globe. Bands of cream, brown, gold, and soft orange wrap around the planet like gentle brushstrokes. The famous Great Red Spot quietly turns within its atmosphere, a storm larger than Earth itself. Yet even this immense storm has existed for centuries. Everything in the outer solar system reminds us that nature measures time differently. Jupiter's gravity is extraordinary. Many comets never pass beyond it. Some are gently captured into shorter orbits. Others are redirected entirely. A few are even thrown back toward the darkness from which they came. Jupiter acts almost like a quiet gatekeeper, not choosing deliberately, simply following the laws of gravity. Our traveler is fortunate. Its path carries it safely onward, not because of luck alone, but because its approach happens at just the right angle, with just the right speed. Tiny differences, measured long ago, have quietly determined today's journey. Astronomers often describe the solar system as a celestial dance. That feels like a beautiful description. No dancer forces another. Each responds naturally to the movement around them. Each step creates the next. Each orbit becomes part of a larger rhythm. Our comet has now entered a new chapter of its long life. For billions of years, it was little more than an unseen frozen world. Now, its path carries it steadily toward sunlight, toward warmth, toward change. Yet nothing visible has happened. If you look closely, the comet would still appear dark, silent, frozen. Its ancient ice remains locked beneath layers of dust. The transformation has not yet begun. The sun still feels too distant, but with every passing year, its gentle light grows stronger. Its quiet warmth becomes a little more noticeable. The comet continues drifting inward, patiently, gracefully, as though answering an invitation that was written into the universe long before Earth was born. Imagine floating beside this ancient traveler. There is no engine, no sound, no vibration, only effortless motion. Stars drift slowly behind you. The sun grows brighter ahead. Every mile traveled has taken years. Every gentle turn has required centuries. There is something deeply peaceful about such unhurried progress. The comet never worries about arriving. It simply continues. One orbit, one century, one quiet moment after another. Soon, for the first time in perhaps millions of years, the warmth of the sun will begin reaching beneath its dusty surface. Ancient ice, which has remained perfectly frozen since the birth of the solar system, will finally awaken, not by melting, but by changing directly from solid ice into invisible gas. It will be the beginning of one of the most beautiful transformations in astronomy. A dark, forgotten world will slowly become a glowing traveler visible from Earth. In our next chapter, we will witness that remarkable awakening as sunlight gently stirs billions of years of sleeping ice. Our quiet traveler has now crossed an invisible boundary. For billions of years, the sun was little more than a distant lantern. Its light was beautiful, but too weak to change anything. Now, with every slow orbit, the warmth grows just a little stronger. Not enough to feel, not enough to melt ice, but enough to begin one of the quietest transformations in nature. Imagine standing outside on the first morning after a long winter. The air is still cold. Snow still covers the ground. Yet something has changed. The sunlight lingers just a little longer. The seasons have begun turning. You cannot see the change happening, but you know it has started. The comet experiences something similar. Its surface still appears dark, still silent, still ancient. Yet deep beneath its dusty crust, the first whispers of warmth slowly arrive. Take a slow breath and picture the comet drifting through endless black space. No sound surrounds it. No atmosphere carries the warmth. Only sunlight, traveling across millions of miles. Every tiny beam left the sun many minutes ago. Now, it gently settles onto the comet's rough surface. The sunlight does not strike with force. It simply arrives, patiently, steadily, day after day, century after century. Slowly, the uppermost layers begin to warm, only by a few degrees, then a few more. The change is almost impossible to measure, yet nature often works through tiny differences. On Earth, we are familiar with ice melting into water. A snowflake lands upon your hand, becomes a tiny droplet, and then disappears. But space tells a different story. There is almost no air surrounding the comet. The pressure is so incredibly low that liquid water cannot exist for long. Instead, something more remarkable happens. The ancient ice skips an entire step. Without becoming liquid, it transforms directly into invisible gas. Scientists call this process sublimation. It may sound like a complicated word, yet the idea is wonderfully simple. Imagine a piece of dry ice sitting on a table. Instead of melting into a puddle, It slowly gives off a ghostly white mist. That mist forms because frozen carbon dioxide changes directly into gas. Many of the ices inside a comet behave in much the same way. Water ice, carbon dioxide, carbon monoxide, methane, and ammonia all begin responding to the growing warmth. Each awakens at a slightly different temperature. Some begin releasing gas while the comet is still far beyond Jupiter. Others wait until it comes much closer to the sun. It is almost like a quiet orchestra. Each frozen ingredient joins the music at its own gentle moment. For billions of years, tiny pockets of these frozen gases have rested peacefully beneath the comet's surface. Now, they begin stretching outward. The gas searches for the easiest path toward open space. Sometimes it slips through tiny cracks. Sometimes it pushes beneath fragile layers of dust. Sometimes it gently lifts loose grains into the darkness. No explosion. No violence. Only steady pressure, building little by little. Imagine breathing beneath a thick blanket of fresh snow. Eventually, the warmth of your breath finds a tiny opening. It escapes softly into the cold air. The comet behaves in a similar way. Invisible streams of gas quietly emerge through small openings scattered across its surface. Astronomers call these streams jets. If you were floating nearby, you might never hear them. Space carries no sound. You would simply see delicate fountains of invisible gas carrying tiny dust particles away from the comet. Some jets remain active for weeks. Others fade after only a few days. As the comet slowly rotates, different regions take turns facing the sun. One side warms, another cools, then the cycle gently repeats. No two comets awaken in exactly the same way. Each carries its own history, its own layers of ice, its own hidden cracks and ancient scars. Some release graceful curtains of dust. Others produce dozens of narrow jets. Some remain surprisingly quiet. Others become unexpectedly active. Every comet has its own quiet personality. Scientists love studying these differences. Each observation reveals another clue about conditions that existed when the solar system was still young. In many ways, watching a comet awaken is like opening a history book written more than 4.5 billion years ago. Each grain of dust has traveled through nearly all of solar system history. Some minerals inside that dust may even be older than our sun. Imagine holding something that existed before Earth had oceans, before mountains, before continents. That is exactly what space missions have accomplished. Tiny grains collected from comets have helped scientists understand how our planetary neighborhood first came together. As more gas escapes, the comet slowly loses a little of itself. It is shedding ancient material into space, not enough to disappear, only enough to create something extraordinary. Around the dark nucleus, a faint cloud begins forming. At first, it is almost impossible to notice. Only a thin veil surrounds the frozen world. Yet hour after hour, day after day, the cloud quietly grows larger. Billions upon billions of tiny molecules drift outward in every direction. Dust follows alongside them. The comet is beginning to glow, not because it creates its own light, but because sunlight gently reflects from the expanding cloud. What was once nearly invisible now becomes easier to see. A patient traveler, hidden for billions of years. is quietly announcing its arrival. If you watch from Earth, you might notice only a faint fuzzy patch among the stars. Nothing dramatic, nothing sudden, just a soft little visitor, gradually becoming brighter each passing night. There is something deeply comforting about this transformation. The comet never hurries. It allows sunlight to do its work, one gentle beam at a time, one invisible molecule at a time, one quiet century leading naturally into the next. Perhaps there is wisdom in that. Not every change needs to happen quickly. Some of the most beautiful transformations unfold so slowly that we notice them only by looking back. Our ancient traveler continues falling inward. The invisible cloud surrounding it keeps growing. Soon, that cloud will become astonishingly large, far larger than the comet itself. In fact, larger than many planets. And yet, it will remain so incredibly thin that it would feel emptier than the finest vacuum ever created on Earth. In our next chapter, we will drift beside this magnificent expanding cloud and discover the gentle mystery of the coma, the glowing halo that transforms an ordinary frozen world into one of the most beautiful sights in the night sky. Our ancient traveler has now crossed another quiet threshold. The invisible streams of gas continue rising from its frozen surface, one gentle breath after another. At first, they drift away unnoticed. Individual molecules spread into the darkness. Tiny grains of ancient dust follow behind them. Each particle begins a journey of its own. There is no atmosphere here to hold them close, no wind to carry them in a particular direction. Only the silent emptiness of space, welcoming everything that leaves the comet. As the hours pass, then days, then weeks, the escaping gas forms a delicate cloud around the nucleus. This cloud has a beautiful name. Astronomers call it the coma. The word comes from an ancient Greek expression meaning long hair. It is an elegant description. From Earth, the soft cloud often makes the comet appear fuzzy, almost as though it were wrapped in a glowing veil. Imagine standing in a quiet meadow before sunrise. A thin layer of mist floats gently above the grass. The trees remain visible, yet softened. Nothing is hidden completely. Everything simply feels gentler. The coma surrounds the comet in much the same way. It does not conceal the nucleus. Instead, it transforms its appearance into something dreamlike. From far away, the comet no longer resembles a dark frozen rock. It becomes a peaceful lantern drifting among the stars. The remarkable part is its size. The comet itself may be only a few miles across, perhaps 10 miles, perhaps 20, small enough to fit comfortably inside a large city. Yet the coma surrounding it grows astonishingly larger, hundreds of miles, then thousands, then tens of thousands. Eventually, it may stretch hundreds of thousands of miles into space. Some especially active comets develop comas more than 1,000,000 miles wide. That is larger than our own Sunday. Imagine placing a tiny pebble in the center of a vast glowing cloud the size of a continent. The pebble is the comet's nucleus. The glowing cloud surrounding it extends farther than anyone standing nearby could ever see. Nature loves such surprising contrasts. Small beginnings often create magnificent results. Yet despite its enormous size, the coma is almost unimaginably thin. If you could drift through it, you might not even notice. There are only a handful of molecules in each cubic inch. On Earth, the finest laboratory vacuum still contains far more particles than the coma surrounding most comets. It is one of astronomy's beautiful paradoxes. Something enormous, yet almost empty. Something bright, yet nearly invisible up close. Its beauty exists because of distance. Sunlight gently enters the expanding cloud. Some rays bounce from tiny dust particles. Others strike gas molecules directly. Those molecules become briefly energized, then quietly release light of their own. Different gases create different colors. Water contributes one part of the story. Carbon monoxide another. Carbon dioxide another still. Sometimes traces of cyanogen, a simple carbon and nitrogen compound, produce faint blue hues. Diatomic carbon, two carbon atoms joined together, often creates a soft green glow. Through powerful telescopes, astronomers sometimes watch these colors slowly changing as the comet approaches the sun. It is almost like watching a flower gradually bloom. Nothing happens suddenly. Every color appears patiently. Every new layer tells another chapter of the comet's story. Imagine floating just outside the coma. Behind you, the stars shine with perfect clarity. Ahead, the glowing cloud surrounds the tiny nucleus like a peaceful halo. Dust drifts silently through space. Individual particles catch the sunlight, then continue their slow outward journey. Some grains are no larger than smoke. Others resemble grains of sand. Each one has traveled unchanged for billions of years. Each may have formed before Earth possessed oceans. There is something humbling about that thought. A single speck of dust, small enough to rest upon your fingertip, can carry a history older than every mountain, every forest, every living creature that has ever walked our planet. Scientists treasure these tiny particles. In 2004, NASA launched a remarkable mission called Stardust. Its goal was wonderfully simple: travel to a comet, collect a few grains from its coma, bring them safely back to Earth. It sounded almost impossible. After all, how do you gently capture dust moving thousands of miles per hour? Engineers found an elegant solution. They used an extraordinary material called aerogel. It is sometimes called frozen smoke because it is incredibly light and almost transparent. As the dust particles entered the aerogel, they slowed gently without being destroyed. Years later, those tiny samples arrived safely on Earth. Scientists examined them carefully. Inside, they discovered minerals that had formed under tremendous heat near the young sun. They also found materials that had remained frozen in the outer solar system. The discovery revealed something fascinating. Long ago, our young solar system mixed its ingredients far more thoroughly than anyone had imagined. Material traveled inward. Material traveled outward. Tiny grains wandered immense distances before settling into comets. Every comet became a quiet collection of many different places, a traveler carrying memories from across the newborn solar system. Our own traveler continues glowing softly. The coma expands a little farther each day. The nucleus slowly rotates beneath its dusty blanket. Some regions face the sun, becoming active. Others slip into shadow, resting quietly once more. The comet breathes almost like a living thing. Not alive, of course, yet it follows a gentle rhythm: warmth, release, rotation, rest, again and again, century after century. Every rotation reveals another hidden pocket of ancient ice. Another quiet jet joins the expanding cloud. Another delicate stream of dust drifts into space. Nothing is wasted. Every escaping particle adds to the comet's growing beauty. If observers on Earth were watching carefully, they might notice the fuzzy visitor becoming brighter night after night. At first, only experienced astronomers would recognize it. Then, with patience, ordinary sky watchers might find it too. A soft glowing patch among familiar stars. Never rushing, never demanding attention, simply inviting anyone who looks upward to pause and wonder. The coma has transformed the comet into something unmistakably beautiful. Yet another masterpiece still lies ahead. Sunlight does more than illuminate the expanding cloud. The sun itself continuously releases an invisible stream of charged particles flowing through the solar system at extraordinary speeds. This gentle but constant river is known as the solar wind. When that invisible wind meets the comet's growing coma, it begins shaping one of the most recognizable sights in all of astronomy. A graceful tail stretching across the darkness, not behind the comet, as many people imagine, but always pointing away from the sun. In our next chapter, we will quietly follow the sunlight and the solar wind to discover the gentle science behind the beautiful tales of comets. Our quiet traveler has now become unmistakably beautiful. The glowing coma surrounds its tiny nucleus like a peaceful lantern. Ancient dust sparkles softly within the sunlight. Invisible gases continue flowing into space. Yet one question still remains. If the coma expands in every direction, why do comets almost always grow long tails? And why? No matter where the comet travels, does its tail always point away from the sun? The answer is one of the most elegant stories in astronomy. It begins with something you cannot see. Take another slow breath and imagine standing beside the comet. Ahead, the sun shines warmly in the distance. Behind you, the darkness of the outer solar system stretches forever. Nothing appears to be moving, yet all around you, an invisible river is constantly flowing. This river is called the solar wind. Despite its peaceful name, it is not wind in the earthly sense. There is no air in space. Instead, the sun continuously releases tiny electrically charged particles, mostly protons and electrons. Every second, billions upon billions of these particles stream outward in every direction. They race across the solar system at incredible speeds, often more than 1 million miles per hour. Yet because space is so wonderfully empty, their journey remains silent. Imagine sunlight itself carrying an invisible breeze, a gentle current flowing endlessly away from the sun. Everything in the solar system quietly experiences this steady outward flow. Most planets are protected by their atmospheres or magnetic fields, but a comet is different. Its delicate coma extends freely into space. When the solar wind reaches this expanding cloud, something beautiful begins to happen. The first tail slowly appears. Astronomers call it the ion tail. Inside the coma, some gas molecules lose tiny electrons after absorbing energetic sunlight. When that happens, they become electrically charged. These charged particles are called ions. The solar wind easily grabs hold of them, almost as though they were tiny leaves floating upon a quiet stream. Slowly, steadily, the ions are carried away from the sun. A long, faint, often bluish tail begins stretching into space. Unlike the comet itself, this tail does not choose its direction. The solar wind chooses for it. That is why the ion tail always points almost directly away from the sun, no matter whether the comet is approaching, leaving, or passing beside our star. Its ion tail faithfully points outward. Nature quietly follows its own invisible rules. But another story unfolds at the very same time. Remember the ancient dust escaping from beneath the comet's surface. Those tiny grains also drift into space. Unlike ions, dust particles are not easily carried by the solar wind. Instead, they respond to something gentler, sunlight itself. Although sunlight feels weightless, every tiny beam carries a minute amount of momentum. Each photon, the smallest packet of light, delivers an almost unimaginably tiny push. One photon accomplishes almost nothing, yet the sun releases an astonishing number of photons every second. Together, they create a delicate pressure. Scientists call this radiation pressure. Imagine standing beneath a gentle spring breeze while holding a feather. The breeze barely touches your skin, yet the feather slowly drifts away. Sunlight acts in much the same way upon tiny dust grains. Patiently, constantly, it nudges them outward. These drifting dust particles create the comet's second tail, the dust tail. Unlike the ion tail, the dust tail does not point perfectly away from the sun. The dust grains continue carrying some of the comet's own forward motion. As sunlight gently pushes them, they form a broad, slightly curved ribbon across the sky. If you have ever seen photographs of bright comets, you may have noticed this graceful curve. It resembles silk flowing behind a dancer, or perhaps the wake behind a peaceful boat gliding across a calm lake. Each dust grain follows its own slightly different path. Together, they paint one of nature's most elegant masterpieces. Sometimes, the two tails become easy to distinguish. A straight blue ion tail, a broader white or golden dust tail, both beginning from the same quiet nucleus, both telling different parts of the same story. There is something deeply poetic about this. The comet itself never creates the tail. The sun does. Without sunlight, the comet would remain dark, silent, and almost invisible. The very thing that slowly wears the comet away also reveals its beauty. Perhaps many beautiful things in nature follow that pattern. The forces that change us also allow us to shine. Imagine floating several hundred miles from the comet. The nucleus appears tiny, almost insignificant. The coma surrounds it like a glowing pearl. Behind it, the dust tail stretches millions of miles through the darkness. The blue ion tail reaches even farther. Both tails remain incredibly thin. You could fly straight through them without noticing any resistance. Yet from millions of miles away, they become breathtaking. Some comet tails grow longer than 100 million miles, long enough to stretch farther than the distance between Earth and the Sun. Few natural structures become so enormous, yet their beauty comes from countless tiny pieces working together. individual molecules, tiny grains of dust, minute pushes from sunlight, invisible streams of charged particles. Nothing acts alone. Everything contributes. Astronomers sometimes observe sudden changes within a comet's tails. A stronger burst of gas may create a brighter stream. Occasionally, a magnetic disturbance in the solar wind causes part of the ion tail to disconnect completely. For a brief time, it appears as though the comet has lost its tail. Then, almost immediately, a new one quietly begins growing. The comet simply continues its journey, patient, graceful, always responding to the invisible environment around it. As the comet approaches the inner solar system, its tails become brighter, longer, easier to see. People on Earth begin noticing the mysterious visitor. Some rise before dawn to search the eastern sky. Others wait until evening twilight fades. Families gather beneath quiet skies. Children point upward. Experienced astronomers adjust their telescopes. For a few peaceful weeks, perhaps a few months, the ancient traveler becomes part of human life. Then, slowly, it moves onward once again. There is something comforting about knowing that these magnificent tales are temporary. They remind us that beauty does not always last forever. Sometimes, its brief appearance is exactly what makes it so precious. The comet continues following its ancient path, its glowing tails flowing gently behind it, always reaching away from the sun. Ahead, another story awaits. Long before telescopes, long before spacecraft, people around the world looked up, saw these mysterious glowing travelers, and wondered what they meant. In our next chapter, we will journey through ancient civilizations, discovering how different cultures quietly welcomed the appearance of comets beneath the same timeless stars. Long before telescopes, long before observatories, and long before anyone understood gravity, people still looked upward. The same stars watched over them. The same moon rose and set, and from time to time, a mysterious visitor appeared without warning. A glowing comet, drifting silently across the heavens. To us, a comet is an ancient traveler shaped by sunlight and gravity. But thousands of years ago, its meaning was far less certain. Imagine lying beneath a clear night sky nearly 4,000 years ago. There are no city lights, no airplanes, no satellites, only an endless blanket of stars stretching from one horizon to the other. Every familiar constellation rises exactly where it should. The sky feels dependable, comforting, almost eternal. Then, one evening, something entirely unexpected appears. A soft, glowing object hangs among the stars. Night after night, it changes position. A faint tail begins stretching across the darkness. Nothing in ordinary experience prepares anyone for such a sight. It is only natural that people begin asking questions. What is it? Why has it come? What does it mean? For many ancient civilizations, the heavens seem deeply connected to life on Earth. The movements of the sun determined the seasons. The moon guided calendars. The stars marked the passing of time. If ordinary objects in the sky influenced daily life, then surely an unexpected visitor must carry an important message. So, many cultures viewed comets as signs, not because they were foolish, but because they were careful observers trying to understand an unfamiliar world. Imagine being one of those early sky watchers. You have never heard the word comet. You know nothing about frozen ice beyond Neptune. You simply notice something extraordinary appearing where nothing existed before. Curiosity becomes the most natural response. In ancient China, astronomers became some of history's most dedicated observers of the night sky. For centuries, they carefully recorded unusual celestial events. Comets, eclipses, meteors, and new stars all found their way into detailed records. Some surviving observations are more than 2,000 years old. Rather than simply admiring the sky, these observers measured it, compared it, recorded when objects appeared, where they moved, and how long they remained visible. Many Chinese scholars described comets using beautiful names. Some were called broom stars because their long glowing tails resembled sweeping brushes across the heavens. Others received names inspired by their shape or brightness. Each appearance became another careful entry in an ever-growing history of the sky. Those ancient records remain valuable even today. Modern astronomers sometimes compare historical descriptions with present-day calculations. Together, they help reconstruct the long journeys of famous comets across thousands of years. Far to the west, the people of ancient Babylon also watched the heavens with remarkable care. From tall temples, priests and astronomers studied planetary movements with astonishing patience. Clay tablets preserve observations that continue to impress historians today. Even without telescopes, they recognized repeating patterns among the wandering planets. When unusual visitors appeared, they carefully noted those as well. The ancient Egyptians lived beneath wonderfully clear desert skies. The stars guided travel along the Nile. Their calendar depended upon the yearly appearance of Sirius, the brilliant dog star. Although surviving records mention fewer comets than those of China, the sky remained deeply woven into Egyptian life. Every unusual celestial event inspired wonder. Across the Mediterranean, Greek philosophers approached the mystery differently. Some believed comets floated high within Earth's atmosphere. Others argued they belonged much farther away among the stars. Without instruments, the truth remained difficult to discover. Even brilliant thinkers sometimes reached very different conclusions. That is one of the quiet beauties of science. Knowledge grows gradually. Every generation builds gently upon the questions of those who came before. Not every answer arrives immediately. Sometimes, the question itself is the greatest achievement. On the other side of the world, many indigenous cultures also developed rich traditions surrounding the night sky. Stories passed from one generation to the next explained unusual celestial visitors in ways that reflected local landscapes, beliefs, and histories. Each culture interpreted the heavens through its own experiences. Yet one feeling appears almost universal: wonder. Wherever people lived, whether beside rivers, across deserts, upon islands, or beneath snowy mountains, they paused to watch the unfamiliar light crossing the stars. Imagine an entire village gathering outside after sunset. Children point upward. Elders quietly remember similar events from decades before. Neighbors exchange stories. Some feel excitement. Some feel concern. Others simply stand in silence, captivated by the beauty above them. For a little while, Everyone shares the same sky. The comet becomes a visitor not belonging to any one nation or language. It belongs to humanity itself. Many early interpretations connected comets with kings, harvests, or important changes. When something rare appeared, people naturally searched for meaning. After all, our minds are wonderfully skilled at finding patterns. It is part of being human. Today, we recognize that comets follow predictable orbits shaped by gravity. Yet knowing the science does not diminish their beauty. If anything, it deepens our appreciation. A glowing visitor traveling billions of miles through space, following a path set long before civilization began, may be even more awe-inspiring than any ancient legend. The remarkable thing is this: the comet itself never changed. Only our understanding changed. The same ancient traveler crossed the skies of Egypt. The same object drifted above Chinese astronomers. The same icy world passed over Roman soldiers, Mayan cities, Persian scholars, and Viking sailors. Generation after generation looked upward at exactly the same celestial visitor. Only the stories surrounding it became different. As you rest beneath this imagined night sky, picture those countless observe. RS separated by oceans, languages, and centuries. None of them ever met, yet all shared one quiet moment. Looking upward, watching the same mysterious light glide silently among the stars. There is something comforting in that thought. Across thousands of years, wonder has always united humanity, and the comets, patient as ever, have continued their journeys without hurry. One observer, many centuries later, would finally discover that at least one famous comet was not a new visitor each time it appeared. It was the same traveler, returning again and again, according to a hidden rhythm written into the fabric of the solar system. In our next chapter, we will meet the quiet English astronomer who uncovered that remarkable pattern and forever changed the way humanity understood comets. The night sky has always rewarded those who watch it patiently. Generation after generation, people observe the stars. They noticed the moon's familiar rhythm. They traced the wandering planets. And from time to time, they welcomed another mysterious comet. Most believed each appearance was a completely new visitor. After all, how could anyone know otherwise? A bright comet might appear once, and then vanish for decades, or even centuries. No human lifetime seemed long enough to discover its secret. Yet one quiet observer, living in England during the 17th century, began asking a wonderfully simple question. What if some comets come back? Imagine sitting beside a candle on a peaceful evening. Sheets of handwritten observations cover a wooden desk. Outside, the world has grown silent. Only the gentle scratching of a feather quill breaks the stillness. No computers, no calculators, no electronic telescopes. Only careful mathematics, patient observation, and endless curiosity. This is the world of Edmund Halley, born in London in 1656. Halley developed a fascination with the heavens while still very young. Unlike many people who simply admired the stars, he wanted to understand them. He wanted to uncover the quiet rules guiding their motion. His curiosity eventually carried him across oceans. While still in his 20s, Halley traveled to the island of St. Helena in the South Atlantic Ocean. The skies there revealed stars invisible from Europe. Night after night, he carefully mapped the southern heavens. His work became one of the first detailed star catalogs of the southern hemisphere. Even then, Halley understood something important. The universe reveals its secrets only to those willing to observe carefully. Years later, Halley formed a close friendship with another remarkable thinker, Sir Isaac Newton. Their conversations would forever change science. Newton had developed a revolutionary understanding of gravity. He realized that the same invisible force pulling an apple toward Earth also guides the moon, the planets, and every object moving through space. Gravity became a single elegant explanation connecting heaven and earth. Halley immediately recognized the importance of these ideas. In fact, he encouraged Newton to publish them. Without Halley's persistence, Newton's famous work, Philosophiae Naturalis Principia Mathematica, might never have reached the world in the form we know today. Sometimes, history changes through quiet encouragement rather than grand speeches. Halley possessed another remarkable gift. He noticed patterns others overlooked. As he studied old records of comets, certain details began standing out. Bright comets had appeared in the years 1531, 1607, and 1682. At first glance, they seemed unrelated. 3 different visitors, 3 separate events. Yet Halley compared their paths across the sky, their brightness, their direction of travel, their speed. Slowly, a possibility emerged. Could all 3 actually be the same comet, returning again and again after completing a long orbit around the Sun? It was an astonishing idea. At the time, many astronomers believed comets traveled through space only once. Some imagined they arrived from deep space, past the Sun, and disappeared forever. Halley thought differently. Using Newton's new mathematics, he calculated the orbits as carefully as possible. The numbers suggested something extraordinary. These 3 comets appeared to follow nearly identical paths. Halley made a bold prediction. He proposed that the comet seen in 1682 would return again. Not next year, not even within his own lifetime, but near the end of the year 1758. Think about the patience required for such a prediction. Halley understood he would never witness the answer himself. He was placing his trust in mathematics, gravity, and the quiet order of the universe. There would be no immediate reward. Only future generations could discover whether he had been correct. In many ways, science is an act of trust. Each generation plants seeds whose blossoms may be enjoyed by those yet to come. Edmund Halley passed away in 1742, 16 years before the predicted return. He never saw the sky confirm his remarkable idea. Then, during the winter of 1758, astronomers began searching. Night after night, they examined the heavens. Patiently, carefully, almost exactly as Halley had predicted. The comet appeared once again, quietly emerging from the darkness, following the very path his calculations had described decades earlier. It was one of the greatest triumphs in scientific history, not because anyone controlled the comet, but because humanity had finally understood one small piece of its journey. From that moment onward, the returning visitor became known as Halley's Comet. Not because Halley discovered it. People had watched it for thousands of years. Instead, His name honors the remarkable realization that it was the same traveler returning again and again. Today, we know Halley's Comet completes one orbit approximately every 75 to 76 years. The exact timing changes slightly because the gravity of giant planets gently alters its path. Jupiter nudges it. Saturn offers another quiet adjustment. Even after centuries, gravity continues refining the journey. Nothing in the solar system moves in perfect isolation. Every world quietly influences every other. Imagine how many generations have watched this same comet. Ancient Chinese astronomers, Roman citizens, medieval monks, Renaissance scholars, modern scientists, families standing beneath suburban skies, children looking upward through backyard telescopes, all welcoming the same ancient traveler. Each appearance connects people separated by thousands of years. The comet remains almost unchanged. Only humanity grows older. Perhaps that is one reason Halley's Comet continues to inspire us. It reminds us that some journeys extend far beyond a single lifetime. We may witness only one brief chapter, yet the story itself stretches across centuries. As you drift beneath this peaceful sky, imagine Halley himself looking upward one final time. He knows he will never see the comet's return. Yet he smiles quietly, not because he seeks recognition, but because he trusts that the universe follows beautiful laws, whether anyone is watching or not. And somewhere beyond the planets, the comet continues along its ancient path, patient, faithful, keeping an appointment made long before any human was born. In our next chapter, we will accompany that famous traveler itself, following Halley's Comet through its remarkable journey around the sun, and discovering why this quiet visitor has become the world's most beloved comet. Now, let us leave the study of the astronomers behind and quietly return to the traveler itself. The same comet that inspired ancient sky watchers. The same comet whose return Edmund Halley predicted continues its timeless journey. It has done so for thousands of years, long before cities, long before written language, long before the pyramids rose from the Egyptian desert. Halley's Comet was already circling the sun. Its journey is one of extraordinary patience. Unlike Earth, which completes its orbit every year, Halley's Comet usually requires about 75 or 76 years to finish a single trip around our star. A human child may become a grandparent before the comet returns. Some people are fortunate enough to see it twice. Many see it only once. Others never witness it at all, yet the comet continues faithfully onward, never missing its ancient appointment. Imagine floating beside Halley's Comet far beyond Jupiter. The sun shines softly ahead. The comet appears peaceful. Its nucleus is surprisingly small, only about 9 miles, or 15 kilometers, from end to end. Compared with planets, it is tiny, yet inside this modest frozen world rests material older than Earth itself. Its surface is darker than many people expect. In fact, Halley's nucleus reflects very little sunlight. Fresh snow reflects most of the light that reaches it. The moon reflects much less. Halley's Comet reflects even less than that. Its dusty surface is almost as dark as coal. The darkness comes from a thin blanket of carbon-rich material mixed with ancient dust. For billions of years, This protective layer has quietly covered the ice beneath. Only when sunlight grows stronger does the hidden ice begin revealing itself through delicate jets. If you could stand upon the nucleus, the landscape would feel strangely familiar and completely alien at the same time. Rolling hills, steep cliffs, deep depressions, gentle slopes disappearing into darkness. No rivers, no clouds, no wind, only silence. The gravity would be astonishingly weak. Imagine taking a gentle step. Instead of landing immediately, you might drift gracefully upward before settling back down. A leap that feels ordinary on Earth could carry you dozens of feet into the darkness. Walking here would feel almost like floating. The sky above would remain perfectly black, even with the sun shining. Without an atmosphere to scatter light, the stars would still sparkle brilliantly all around you. Imagine standing on a lonely ridge. The sun glows quietly in one direction. Countless stars surround you in every other. The silence feels endless. In 1986, humanity finally met Halley's Comet up close. Not through a telescope, not through imagination, but with spacecraft. Several nations launched missions to greet the famous traveler during its return. The most ambitious was the European spacecraft Giotto, named after the Italian painter Giotto di Bondone, who included Halley's Comet in one of his famous paintings. The spacecraft embarked on a remarkable voyage. As Giotto approached, scientists waited eagerly. Until then, no one had ever photographed the nucleus of a comet at close range. Many imagined a smooth, frozen snowball. Others pictured something entirely different. The images revealed a world unlike either expectation. A dark, irregular object, scarred by time. Its surface appeared rugged, uneven, covered with cliffs, pits, and ancient fractures. Bright jets burst quietly from several active regions. Instead of glowing everywhere, the comet released most of its gas from only a handful of places. It was a wonderful reminder that nature often prefers complexity over simplicity. Giotto flew astonishingly close, only about 370 miles, or roughly 600 kilometers, from the nucleus, for a spacecraft traveling at enormous speed. This was an extraordinary achievement. Tiny dust grains struck the spacecraft with tremendous force. One impact briefly interrupted communications. Yet Giotto survived. It continued sending precious images back to Earth. Those photographs forever changed our understanding of comets. They revealed that these ancient travelers are active, dynamic worlds, not frozen statues, but slowly evolving bodies shaped by countless journeys around the sun. Every return removes a little more ice. Every orbit changes the landscape. New cliffs appear, old surfaces collapse, fresh cracks open. The comet quietly reshapes itself over time. Imagine reading the rings inside an ancient tree. Each ring tells part of its history. Halley's Comet carries similar memories. Its valleys, its pits, its dust-covered plains. All preserve evidence of billions of years spent traveling through the solar system. Scientists estimate that Halley's Comet has probably completed hundreds, perhaps even thousands, of trips around the Sun before entering its current orbit. It may have wandered for millions of years among the giant planets. Before that, It likely rested quietly in the distant Kuiper belt or perhaps even farther away before gravitational encounters slowly transformed its path. Its story stretches far beyond recorded history. As the comet approaches the sun, its activity reaches a peak. Jets become brighter. The coma expands dramatically. The graceful tails grow longer across the darkness. Then, after passing closest to the sun, the process slowly reverses. The warmth fades. Gas production decreases. The coma begins shrinking. The magnificent tails gradually disappear. One by one, the active jets fall silent. The ancient traveler returns to sleep. Its next visit will not come for another lifetime. There is something wonderfully reassuring about that rhythm. Awakening, shining, resting, returning, again and again, without hurry, without interruption, for countless generations. People have marked the passing of time by Halley's appearances. A child sees it. Many decades later, that child's grandchildren gather beneath another night sky, waiting for the same familiar visitor. The comet quietly connects lives separated by nearly a century. Very few natural wonders offer such a gift. As you continue drifting peacefully beside this ancient traveler, imagine watching Earth becoming smaller behind you. Ahead, the comet continues following its graceful orbit. Its quiet journey is far from over. Halley's Comet is only one member of a much larger family. Throughout the solar system, many other comets follow their own unique paths. Some arrive only once in many thousands of years. Others return more frequently, and in recent decades, humanity has done something once thought impossible. We have landed on one. In our next chapter, we will accompany the remarkable spacecraft that not only visited a comet, but gently touched down upon its ancient surface. For thousands of years, humanity could only admire comets from afar. They appeared quietly in the night sky, glowed for a little while, and then faded back into the darkness. People wondered what they were made of, how they formed, whether they truly were ancient travelers from the birth of the solar system. Telescopes brought us closer. Powerful cameras revealed beautiful details. Yet there remained one dream. What if, instead of simply watching a comet, we could visit one? Imagine standing on a quiet shoreline. For centuries, your family has watched mysterious ships sailing across the distant horizon. You know they exist. You see them passing. But no one has ever stepped aboard. Then, one day, a small boat carries someone across the water. The mystery suddenly becomes something real. That is exactly what happened with comets. Human curiosity finally reached them. The journey began slowly. Each mission carried a simple purpose. Learn a little more. Travel a little farther. Ask another question. No single spacecraft answered everything. Instead, each became another gentle step toward understanding. One of the most extraordinary missions ever launched began in 2004. Its name was Rosetta, named after the famous Rosetta Stone, which helped scholars understand ancient Egyptian writing. The spacecraft hoped to unlock another ancient language, the language written inside comets. Its destination was a small comet known as 67P/Churyumov-Gerasimenko. The name may sound complicated, so many people simply call it Comet 67P. Reaching it would require remarkable patience. Unlike traveling to a nearby planet, Rosetta needed more than 10 years to arrive. Think about that. A spacecraft launched while children were still in elementary school finally reached its destination after many of those children had become adults. Space exploration teaches patience better than almost anything else. During its long voyage, Rosetta circled the sun several times. It borrowed tiny boosts of speed from Earth and Mars through graceful gravitational flybys. Each encounter gently reshaped its path. Much like the comets themselves, the spacecraft relied upon gravity rather than brute force. At last, in 2014, Rosetta caught up with its ancient companion. For the first time in history, a spacecraft entered orbit around a comet. Imagine floating quietly beside this strange little world. It did not resemble a smooth snowball. Instead, its shape reminded many people of a rubber duck, two uneven lobes connected by a narrow neck. Its surface appeared rugged, covered with towering cliffs, deep pits, smooth, dusty plains, and scattered boulders. Sunlight illuminated one side. The opposite side remained wrapped in darkness. Every few hours, the comet slowly rotated beneath the silent spacecraft. Rosetta watched patiently, day after day, week after week. As the comet traveled closer to the sun, scientists witnessed something remarkable. The quiet world slowly awakened, exactly as we have imagined together. Tiny jets appeared first, then larger fountains of gas and dust. The coma gradually expanded. The comet changed before their eyes. For the first time, humanity was watching a comet wake from nearby, not through distant telescopes, but from only a few miles away. Then came one of the boldest moments in space exploration. Rosetta carried a small companion, a lander named Philae. Its mission sounded almost impossible. Touched down on a comet whose gravity was so weak that even the gentlest bounce might send it drifting back into space forever. Imagine trying to land upon a slowly spinning mountain, while both you and the mountain are traveling tens of thousands of miles per hour around the sun. That was the challenge. Everything depended upon precision. In November of 2014, Philae quietly separated from Rosetta. Very slowly, it drifted toward the surface. There was no roaring engine, no fiery descent, only a peaceful fall lasting several hours. Scientists around the world waited. The signal required nearly half an hour to travel between Earth and the spacecraft. Everything happening had already occurred long before anyone received the news. Finally, confirmation arrived. Philae had touched the comet, but the landing was not exactly as planned. Small harpoons designed to anchor the lander failed to fire. Instead of remaining firmly attached, Philae bounced, then bounced again. The weak gravity allowed it to travel almost a mile before finally settling into a quiet resting place beside towering cliffs. Although unexpected, the landing was still historic. Humanity had placed a spacecraft upon a comet for the very first time. Even from its shaded location, Philae accomplished something remarkable. Its instruments measured the comet's surface. They analyzed dust. They detected organic molecules, the carbon-based compounds that are among the building blocks of life. These molecules were not living, yet they reminded scientists that comets preserve complex chemistry from the earliest days of the solar system. Perhaps similar travelers helped deliver some important ingredients to the young Earth billions of years ago. The question remains open, but it is a beautiful possibility. Rosetta continued circling above. For more than 2 years, it observed every quiet transformation. It watched new jets appear. Dust storms drift across the surface. Sunlit regions brighten. Shadowed valleys cool once again. Never before had humanity followed a comet through such an extended part of its journey. Then, in 2016, the mission reached its peaceful conclusion. Engineers guided Rosetta gently downward. Rather than leaving forever, the spacecraft slowly descended, touching the surface of the comet it had faithfully accompanied across the solar system. There it remains today, silent, resting beside ancient ice that formed billions of years ago. It is a strangely comforting image. A human-made explorer, sleeping forever beside one of the oldest objects in our planetary family. Together, they continue orbiting the sun, quietly, patiently, year after year. As you imagine drifting above this peaceful comet, the stars shine all around. The sun glows softly in the distance. Rosetta rests upon the ancient surface. Philae sleeps nearby. And the comet itself continues the journey it began long before Earth had oceans. These remarkable missions answered many questions, yet they also revealed how much remains unknown. Every comet seems slightly different. Each carries its own unique history. Each preserves another chapter from the solar system's earliest days. In our next chapter, we will explore the precious clues hidden inside these frozen travelers and discover why scientists sometimes call comets time capsules from the dawn of the solar system. Every comet is a traveler, but it is something else as well. A messenger, a tiny archive, preserving memories from a time before the planets were fully born. Imagine discovering an old wooden chest hidden inside a quiet attic. Dust covers its surface. Its hinges have not moved for generations. When you gently lift the lid, you find objects untouched for hundreds of years. Each one tells a story, not because it is valuable, but because it has remained unchanged. Comets are very much like those forgotten chests. Only their memories are far older. Not hundreds of years, not thousands, but more than 4.5 billion years. When the solar system first formed, countless tiny grains of dust floated within the young solar nebula. Some grains came from ancient stars that had lived and died even before our sun was born. Others formed inside the cooling cloud itself. Slowly, gravity gathered these tiny particles together. Some became planets, others became moons. A few remained frozen in distant darkness. Those frozen survivors became the comets we know today. Because they spent most of their lives far from the sun, their contents changed very little. While Earth developed oceans, mountains, continents, and life, many comets simply waited, patiently, silently, keeping their ancient secrets frozen inside. Scientists sometimes call them time capsules. It is a beautiful description. A time capsule is something preserved for the future, something that allows later generations to glimpse the past. Every comet carries such a gift. Imagine shrinking until you are no larger than a grain of dust. Now picture yourself drifting through the interior of a comet. Around you, tiny crystals of water ice sparkle faintly. Mixed among them are frozen carbon dioxide, carbon monoxide, methane, and ammonia. Delicate mineral grains lie scattered throughout. Some are older than Earth itself. Tiny organic compounds weave quietly between the ice. Together, they form a remarkably simple mixture. Nothing appears spectacular. No glowing treasure. No hidden machinery. Only ice, dust, and chemistry. Yet these humble ingredients helped shape everything that followed. Scientists often wonder how Earth received its water. When our planet first formed, its surface was unimaginably hot. Any early water may have escaped into space. So where did today's vast oceans come from? One possibility is that countless icy bodies, including comets, collided with the young Earth billions of years ago. Each impact may have delivered small amounts of water, drop by drop, collision after collision, across millions of years. The process would have been slow, gentle only when viewed across immense stretches of time. Today, scientists continue studying this fascinating question. Some comets contain water whose chemical fingerprint differs from Earth's oceans. Others appear more similar. The answer is still unfolding. Perhaps comets supplied part of Earth's water. Perhaps asteroids contributed even more. Or perhaps both played important roles together. Science often advances this way, not through simple answers, but through careful evidence gathered piece by piece. Water is only part of the story. Comets also contain organic molecules. These are carbon-based compounds that serve as important ingredients for life. It is important to remember, organic molecules are not living organisms. They do not think. They do not grow. They are simply complex chemical building blocks. Yet life as we know it depends upon chemistry beginning with such molecules. Imagine baking a loaf of bread. Before the bread exists, you gather flour, water, salt, and yeast. None of those ingredients is bread by itself, but together, they make something entirely new. Organic molecules play a somewhat similar role. They are ingredients, not the finished result. Space missions have found amino acids and other surprisingly complex compounds within comet material. Even before spacecraft arrived, scientists studying meteorites discovered similar molecules preserved inside ancient rocks. The universe appears remarkably skilled at creating chemistry, perhaps long before Earth became a living world. The raw materials were already traveling through space aboard icy visitors. That thought carries a quiet beauty. The atoms inside every living creature, inside every tree, every bird, every flower, and every human being may have shared part of their journey with ancient comets long ago. The oxygen you breathe, the carbon in your body, the water within every cell. Each atom has its own extraordinary history. Many existed before Earth itself. Some were forged inside stars. Others traveled across interstellar space. Eventually, they became part of our planet. And now, they have become part of us. There is something deeply comforting about that connection. We are not separate from the universe. We are one small expression of it. Every comet quietly reminds us of this truth. As Rosetta studied Comet 67P, its instruments detected dozens of different molecules escaping into the coma. Some had never before been observed so clearly around a comet. Each discovery helped scientists understand conditions that existed during the earliest chapters of the solar system. It was almost like reading pages from an unimaginably ancient diary. Every molecule became another sentence. Every dust grain, another word. Every jet of gas, another clue. The story is still being translated. Imagine holding one tiny grain collected from a comet. It feels almost weightless. It appears ordinary. Yet hidden inside is a history stretching back billions of years. No museum artifact on Earth is older. No ancient manuscript reaches so far into the past. That tiny grain has witnessed the birth of planets, the formation of oceans, the rise of mountains, the appearance of forests, the evolution of countless living creatures, and finally, our own arrival beneath the stars. Perhaps that is why scientists continue sending missions toward these distant travelers. Not simply because comets are beautiful, although they certainly are, but because every comet carries another piece of humanity's oldest question. Where did we come from? The answer is unlikely to be found in one single object. Instead, it rests quietly across many worlds. Asteroids, planets, moons, and ancient comets. Together, they preserve the story of our beginnings. As you drift peacefully beside this frozen traveler, imagine its quiet heart still holding countless undiscovered secrets. Tiny crystals of ice, ancient grains of dust, and delicate molecules older than Earth itself. The comet asks for nothing. It simply carries its memories through the darkness, waiting patiently for anyone willing to listen. In our next chapter, we will discover that comets speak in another surprising way as well. Not with words, but with invisible whispers carried through space, revealing a quiet voice that scientists have learned how to hear. Most of us imagine space as perfectly silent, and in one important way, it truly is. Sound, as we know it on Earth, cannot travel through empty space. There is no air, no gentle breeze, no atmosphere to carry vibrations from one place to another. If you were floating quietly beside a comet, you would hear nothing at all. No crackling ice, no rushing gas, no whispering dust, only perfect silence. Yet, in another sense, comets do have a voice, not one our ears can hear, but one our instruments have slowly learned to understand. Imagine sitting beside a peaceful stream at night. You cannot see the water clearly, yet by listening, you begin to understand its movement. The quiet splashing tells you where the current is strongest. The softer ripples reveal calmer places. Even without seeing, you learn something important. Scientists sometimes do something similar with comets. Instead of ordinary sound, they listen to invisible signals. The solar system is filled with electrical activity. The sun constantly sends out its solar wind, that endless river of charged particles we visited earlier. As those particles encounter a comet, they interact with the expanding cloud of gas surrounding it. Tiny ions become trapped inside invisible magnetic fields. Electrons dance through the coma. Magnetic waves ripple outward. These motions cannot be heard directly, but spacecraft can detect them. Sensitive instruments record changes in electric and magnetic fields. Later, scientists transform those measurements into sounds that human ears can enjoy, not because the comet literally sings, but because translating the data helps reveal hidden patterns. The result is strangely beautiful. Gentle whistles, soft pulses, delicate rising tones. Sometimes they resemble distant wind, sometimes quiet birdsong, sometimes the peaceful hum of an unseen instrument. Each sound represents something real happening around the comet. It is the invisible becoming audible. During the Rosetta mission, one discovery surprised scientists around the world. As the spacecraft orbited Comet 67P, its instruments detected slow oscillations within the comet's magnetic environment. When converted into sound, they produced a haunting, gentle melody. Many people described it as eerie. Others found it calming. Some said it sounded almost alive. Imagine drifting through endless darkness. Far below, the ancient comet slowly rotates. Invisible magnetic waves flow around it. Your spacecraft quietly records every tiny change. Later, back on Earth, those invisible rhythms become music for curious human ears. It is one of the rare moments when science allows us to experience something normally beyond our senses. Of course, the comet itself is not creating music intentionally. Nature has no audience in mind. The magnetic waves arise naturally from the meeting between sunlight, the solar wind, and the expanding gases surrounding the comet. Yet there is something deeply moving about discovering beauty hidden inside mathematics. Imagine throwing a pebble into a perfectly still pond. Circular ripples spread outward. Although invisible in space, similar waves can travel through clouds of charged particles. Instead of water, they move through plasma. Plasma is often called the fourth state of matter. It is neither solid, nor liquid, nor ordinary gas. Instead, it consists of electrically charged particles moving freely together. The sun is made mostly of plasma. Lightning briefly creates plasma. Much of space itself is filled with it. Around an active comet, plasma becomes part of a graceful conversation between the sun and the icy traveler. The solar wind arrives first. The comet responds by releasing gas. Magnetic fields shift. Charged particles accelerate. Invisible waves spread quietly through the surrounding space. Nothing collides violently. Everything simply responds to everything else. It is less like an explosion and more like a conversation carried out without words. Rosetta observed this conversation for more than 2 years. As the comet approached the sun, its activity increased. The invisible waves changed. New patterns appeared. Scientists watched these subtle transformations almost as meteorologists study changing weather on Earth. Except this weather existed in space itself. Imagine standing beside a forest at dawn. One morning, only a few birds are singing. Several weeks later, spring has arrived. The forest becomes filled with gentle voices. The place has awakened. Something similar happened around the comet. As sunlight warmed the ancient ice, its invisible environment gradually became richer and more active. The comet seemed to awaken not only visually, but electrically as well. There is something wonderfully humbling about this discovery. Our senses reveal only a tiny portion of reality. Our eyes see only one small range of light. Our ears hear only certain vibrations. Yet the universe is filled with patterns beyond ordinary perception. Science does not replace wonder. It expands it. Every new instrument becomes another sense. Radio telescopes allow us to see invisible radio waves. Infrared cameras reveal hidden warmth. Particle detectors uncover invisible cosmic visitors. Magnetometers let us hear silent conversations taking place around distant comets. Little by little, the universe becomes richer than we ever imagined. And still, most of it remains wonderfully mysterious. Perhaps that is exactly as it should be. A universe with no mysteries would soon become ordinary. Instead, every answer gently opens another question. Every discovery invites another journey. As you drift peacefully beside this ancient traveler, imagine the invisible solar wind flowing around you. Gentle magnetic ripples spread through the darkness. No ordinary sound reaches your ears, yet somewhere inside the instruments of a nearby spacecraft, the quiet voice of the comet is being faithfully recorded. Not a song in the human sense, but a subtle rhythm written into the invisible fabric of space itself. Even silence, it seems, can carry remarkable stories. Soon, our ancient traveler will begin moving farther from the warmth of the sun. Its brilliant tales will slowly fade. Its glowing coma will shrink. Its long season of activity will gently come to an end. In our next chapter, we will quietly follow the comet as it leaves the inner solar system and discover the peaceful rhythm of its endless returning journey through the darkness. Every journey has two directions. There is the path toward the light, and the path leading gently away from it. For a comet, both are equally important. We have followed our ancient traveler as it awakened beneath the growing warmth of the sun. We watched frozen ice become flowing gas. We admired its glowing coma. We traced its graceful tails across the darkness. Now, the brightest part of its voyage has quietly passed. The comet begins turning outward once more. Imagine watching a traveler leave a peaceful village at sunrise. At first, the houses remain close behind. Voices can still be heard. The warmth of morning lingers. But with every gentle step, the village becomes smaller. The sounds fade. The air grows cooler. Eventually, only the quiet road remains. A comet experiences something remarkably similar. After passing closest to the sun, astronomers call the point perihelion. Its long journey outward begins. Day by day, the sunlight weakens, only slightly at first. The difference is almost impossible to notice. Yet the comet notices. The active jets that once burst from hidden cracks begin slowing. Less ice turns into gas. Less dust escapes into space. The brilliant coma starts becoming thinner. Its glowing veil grows smaller. The magnificent tails, which stretched for millions of miles, slowly fade into invisibility. There is no sudden ending, no dramatic farewell, only a gradual return to stillness. Imagine watching mist disappear from a quiet meadow after sunrise. Minute by minute, it becomes lighter, softer, more transparent, until one day, you suddenly realize it is gone. The comet's transformation follows the same gentle rhythm. Soon, its nucleus is visible only as a small, dark, silent world once again. The long season of activity has come to rest. Its brief performance beneath the sun has ended. Now, it simply continues traveling, patiently, steadily. The farther it moves, the colder its surroundings become. Near Jupiter, the warmth of the sun has already diminished greatly. Beyond Saturn, sunlight feels surprisingly faint. Farther still, near Uranus and Neptune, The Sun resembles an exceptionally bright star rather than the brilliant disk we know from Earth. Its light still reaches the comet, but only as a gentle reminder of immense distances. The surface grows colder, layer by layer. Remaining gases freeze once again. Fresh frost settles upon ancient ground. The cracks that once released fountains of vapor become quiet. The coma disappears completely. Nothing remains except the nucleus itself, a frozen traveler sleeping peacefully beneath endless stars. If you were drifting beside it now, you might wonder whether it had ever been active at all. No tails, no glowing cloud, no jets, only silence, only darkness, yet hidden beneath the surface. The memory of sunlight waits patiently. The comet has not died. It is merely resting. This quiet cycle repeats again and again through countless orbits. Every return to the inner solar system removes a little material. Every visit changes the landscape ever so slightly. Tiny cliffs collapse. Fresh cracks appear. Ancient ice disappears forever. Dust settles in new places. The comet slowly evolves. Scientists estimate that many short-period comets eventually lose much of their easily vaporized ice. After enough journeys, they become less active. Their once spectacular displays grow fainter. Some eventually resemble dark asteroids more than brilliant comets. Others break apart completely. A large fracture may split the nucleus into several pieces. Each fragment continues its own quiet journey around the Sun. Sometimes Earth later passes through the dusty trail left behind. When that happens, those tiny grains enter our atmosphere at tremendous speed. They burn high above us, creating beautiful meteor showers. Imagine looking upward during a peaceful August night. A bright streak flashes across the stars, then another, and another. Those graceful meteors may be tiny fragments released by a comet centuries ago, long after the comet itself has moved onward. Its scattered dust continues visiting Earth. There is something wonderfully poetic about this. A traveler leaves behind small reminders of its passing, just as footprints remain briefly in fresh snow. A comet leaves invisible pathways of dust across the solar system. Earth quietly crosses some of those pathways every year. The famous Perseid meteor shower comes from debris left by Comet Swift-Tuttle. The Leonids arise from Comet Tempel-Tuttle. Many other meteor showers trace their origins to ancient cometary journeys. Each falling star reminds us that comets continue sharing tiny pieces of themselves with the solar system, not through dramatic collisions, but through gentle gifts scattered across space. Imagine floating far beyond Neptune once again. The solar system feels enormous. The planets appear as distant lights. Our comet continues drifting outward. Its orbit carries it into colder and quieter regions, perhaps toward the Kuiper Belt, perhaps even farther, depending upon its particular path. Years become decades. Decades become centuries. Nothing seems hurried. Nothing feels urgent. Space itself teaches patience. The comet has all the time it could ever need. Eventually, gravity begins its quiet work once more. The Sun, though distant, never completely releases its gentle hold. The orbit slowly curves. Almost imperceptibly, the outward journey reaches its farthest point. Astronomers call this place aphelion, the greatest distance from the Sun. Here, Our traveler seems almost suspended between journeys. It pauses, not by stopping, but by changing direction so gradually that the moment is nearly impossible to notice. Then, without fanfare, the return begins. The sun slowly grows brighter once again. Not today, not tomorrow, perhaps not for many years, but little by little, the warmth increases. The long cycle quietly repeats itself, awakening, shining, resting, returning. This rhythm has continued for millions, sometimes billions, of years, long before humans first looked upward, long before telescopes, long before history itself. The comets were already following these elegant paths. There is something deeply comforting in such steady rhythms. The universe does not rush. The stars do not hurry across the sky. Planets patiently complete their orbits. Galaxies turn almost too slowly to notice. And comets, the ancient wanderers, continue honoring appointments written into gravity itself. As you drift beside this sleeping traveler, allow its peaceful rhythm to become your own. There is no need to hurry, no need to force the journey. Everything unfolds in its proper time. Every return arrives when it is meant to. Soon, we will follow one final voyage, not only the path of a single comet, but the quiet lesson these ancient travelers leave for all who pause to watch them. In our next chapter, we will accompany our timeless wanderer on its last gentle passage through the inner solar system, reflecting on the remarkable story it has carried across billions of years beneath the endless stars. Every traveler, no matter how ancient, eventually reaches a final chapter, not always a dramatic ending. Sometimes, simply the quiet completion of a very long story. Our comet has spent billions of years crossing the solar system. It has awakened beneath the warmth of the sun, fallen asleep again in the distant darkness, and repeated that peaceful rhythm more times than anyone could count. Each return has changed it, just a little. A little more ice has disappeared. A few more cliffs have crumbled. Another delicate layer of dust has settled across its surface. Time leaves gentle fingerprints on everything. Imagine an old sailing ship that has crossed the same ocean for centuries. Each voyage wears the wood a little thinner. The sails become patched. The paint slowly fades beneath countless sunrises and storms. Yet the ship continues sailing, not because it is unchanged, but because it has learned how to endure. A comet is much the same. Its voyages leave quiet marks upon its frozen body. With every close passage by the sun, it gives away a tiny part of itself. A little water vapor, a little carbon dioxide, a few grains of ancient dust, tiny gifts scattered across the solar system. The losses seem almost insignificant. One orbit changes very little. Even 10 or 20 orbits make only a modest difference. But billions of years are wonderfully patient. Small changes become great transformations. Scientists estimate that many comets eventually exhaust much of the easily accessible ice near their surfaces. The active jets grow weaker. The glowing coma becomes smaller. The magnificent tails no longer stretch across the sky with their former brilliance. The traveler grows quieter. Its performances become shorter, gentler, almost shy. Imagine lighting a candle each evening. Night after night, the flame burns warmly. The candle always appears much the same. Yet with every passing hour, the wax slowly disappears. The flame itself is beautiful, but it cannot burn forever. A comet shines in a similar way. Its beauty comes from giving away tiny pieces of itself. Without losing material, there would be no glowing coma, no graceful tails, no celestial display. Its brilliance is inseparable from its slow transformation. There is something quietly moving about that truth. Sometimes, the things that make us beautiful also change us. Not all comets simply fade away. Some experience more dramatic endings. As sunlight warms hidden pockets beneath the surface, pressure may build inside ancient cracks. Eventually, a section of the nucleus can collapse. Sometimes, the entire comet splits into several pieces. Each fragment continues traveling independently. Imagine an ancient iceberg slowly breaking apart on a quiet sea. Each piece drifts onward, still carrying the memory of the original whole. Astronomers have witnessed this happening many times. One famous example was Comet Shoemaker Levy 9. Long before it reached the Sun, the immense gravity of Jupiter pulled the comet apart into a chain of separate fragments. Instead of one traveler, there were many. In 1994, those fragments plunged into Jupiter's enormous atmosphere. The impacts created dark scars larger than Earth itself. Even events of tremendous scale, when viewed from the quiet distance of space, unfold with remarkable silence. Other comets simply become inactive. Their icy surfaces eventually become covered by thick blankets of dust. Fresh ice lies hidden too deeply for sunlight to reach. The comet continues orbiting, but no longer awakens as it once did. To distant observers, it may resemble an ordinary dark asteroid. Only its long history reveals its true identity. Scientists sometimes call these objects extinct comets. I rather like another way of imagining them. Sleeping travelers, not entirely gone, simply changed. Their brightest seasons have passed, yet they continue circling the sun, still following the same ancient paths written by gravity long ago. Imagine floating beside one of these quiet worlds. No tails, no jets, no glowing clouds surrounding it. Only a dark, weathered surface beneath the endless stars. If you did not know its history, you might never guess that this peaceful object once inspired kings, guided astronomers, and filled the night sky with radiant light. Its greatest adventures now belong to memory, and yet, its journey continues. There is comfort in that thought. Not every ending requires disappearance. Sometimes, an ending is simply another form of becoming. Our own sun reminds us of this gentle truth. It too will not shine forever. Billions of years from now, after exhausting the hydrogen within its core, it will slowly expand into a red giant. The inner planets will experience extraordinary change. Comets still wandering through the distant solar system may awaken one final time beneath the sun's growing warmth. Some may evaporate completely. Others may be scattered forever into interstellar space. The solar system itself will slowly become something new. Even stars, it seems, live according to peaceful cycles. Yet none of this belongs to tomorrow, or next year, or even the next million years. These are stories measured across timescales so immense that they almost resemble eternity. For now, Our comet continues its faithful orbit. Its next return may arrive decades from now, or centuries, perhaps thousands of years, depending upon its path. Some future child, not yet born, may stand beneath a quiet evening sky, look upward, and notice a familiar glowing visitor stretching across the stars. That child will inherit the same sense of wonder shared by ancient sky watchers thousands of years ago. The comet will have become a bridge between generations once again. There is something deeply peaceful about knowing that beauty can outlive those who admire it. The stars do not belong to one lifetime. Neither do the comets. They quietly wait for whoever comes next. As our traveler drifts farther into the darkness, its brilliant display has now faded completely. Only the tiny frozen nucleus remains. The solar system grows still around it. The sun shines softly in the distance. The great planets continue their patient revolutions. Everything moves according to rhythms older than memory. Our journey with this remarkable traveler is almost complete. Only one final chapter remains. Not a chapter about science alone, or history, or distant spacecraft, but about the quiet feeling these ancient wanderers leave within us. As you continue drifting peacefully through the darkness, allow the stars to become a little softer, the silence a little deeper, and your breathing a little slower. In our final chapter, we will rest beneath the timeless sky one last time, reflecting on what the ancient travelers have quietly taught us about patience, wonder, and our own small place within the endless universe. Our journey is almost complete. The ancient traveler has faded into the quiet darkness once again. Its glowing tail has disappeared. Its shining coma has become only a memory. Ahead lies another long orbit through the cold outskirts of the solar system, where silence stretches farther than imagination. Behind us, billions of years of history quietly drift through space. If you could look back upon everything we have explored together, you might notice something surprising. This has never really been a story about a comet alone. It has also been a story about time, about patience, about the remarkable way the universe allows beautiful things to unfold without ever feeling hurried. Imagine lying peacefully beneath a clear night sky. The air is cool. A gentle breeze brushes softly across your face. Far above, countless stars shimmer with quiet confidence. Some are nearby. Others are so distant that their light began traveling toward Earth long before the first human civilizations appeared. And somewhere among those endless lights, far beyond what your eyes can easily see, an ancient comet quietly follows its timeless path. It asks for nothing. It rushes nowhere. It simply continues. There is comfort in that. Our lives often feel busy. Days become weeks. Weeks become years. We hurry from one moment to the next, rarely noticing how extraordinary ordinary life truly is. Yet the universe moves differently. The Earth takes an entire year to circle the sun. The moon patiently completes its monthly journey around our planet. Jupiter needs nearly 12 Earth years to finish one orbit. Neptune requires more than 160. Many comets take centuries. Some require thousands of years before returning to the warmth of the inner solar system. Nothing in the heavens seems impatient. Everything unfolds according to quiet rhythms older than memory itself. Perhaps that is one reason people have always looked upward. The night sky gently reminds us that there is no need to race through existence. Imagine one final evening. A family stands outside together beneath a peaceful sky. A child notices a bright object with a glowing tail. "What is that?" they ask softly. An older voice smiles before answering. "That is a comet." Perhaps the child has never seen one before. Perhaps the older person has waited their entire lifetime for its return. For a few quiet nights, both generations share the same moment of wonder. Then, the visitor slowly fades once again. Years later, the child grows older. Perhaps they become a scientist, perhaps a teacher, perhaps simply someone who still enjoys looking upward on quiet evenings. One day, they tell the same story to another curious child. In this gentle way, comets travel not only through space, but through human memory as well. They connect generations that never meet. They remind us that wonder can be passed from one heart to another. Long before telescopes, people stood beneath these same stars. Long before spacecraft, they watched these glowing visitors with curiosity. Today, we understand much more than our ancestors ever could. We know that comets formed when the solar system itself was still young. We know about the Oort cloud, the Kuiper belt, and the quiet influence of gravity. We understand how sunlight awakens frozen ice, how delicate tails stretch across millions of miles, and how spacecraft have gently touched these ancient worlds. Yet for all our knowledge, the feeling remains wonderfully familiar. We still pause. We still look upward. We still experience that quiet sense of awe. Science has not taken away the mystery. It has simply revealed that reality is even more beautiful than imagination first believed. Think for a moment about the atoms inside your own body, the oxygen filling your lungs, the calcium within your bones, the iron carried by your blood. Nearly every atom was forged inside ancient stars that lived and died long before our sun was born. The water flowing through every living cell has traveled an astonishing journey across cosmic history. Some ingredients that helped shape our world may have arrived aboard icy visitors, much like the comets we have followed together. In a very real sense, the universe is not something separate from us. We are one small chapter within its ongoing story. Carl Sagan once expressed a similar idea when he wrote that we are made of star stuff. It is a simple phrase, yet perhaps no sentence better captures the quiet relationship between ourselves and the cosmos. We are children of ancient stars, living beneath ancient travelers. Imagine drifting one final time beside our peaceful comet. Its surface is dark. Its ice sleeps beneath protective layers of dust. Around it, space stretches endlessly in every direction. No engines, no voices, no clocks, only distant starlight, and the steady pull of gravity guiding the next long orbit. Far away, the sun shines like a brilliant lantern. Even from this enormous distance, its gravity continues reaching outward, patiently, faithfully. One day, perhaps decades, perhaps centuries, perhaps much longer, the comet will answer that silent invitation. It will begin another slow return. The ice will awaken once more. A new coma will bloom. Fresh tales will unfurl into the darkness. Another generation will lift curious eyes toward the heavens. Another story will quietly begin. Until then, Our traveler rests, and perhaps, so can we. Take one slow breath. Feel the gentle rhythm of your breathing. Imagine the stars above becoming softer, their light blending gently into the quiet darkness. The planets continue their endless circles. The distant galaxies turn almost too slowly to notice. Ancient comets drift peacefully through the cold beyond Neptune. And here, on our small blue world, beneath an ocean of stars, you are part of that same magnificent universe. The night remains calm. The sky remains endless. The ancient travelers continue their silent journeys. And somewhere, far beyond the reach of ordinary sight, a small frozen comet carries its timeless memories through the darkness, waiting patiently for another sunrise, another orbit, and another quiet soul to look up and wonder. Good night.